Well, with this video, we start the chapter on acids and bases, and the acids and bases are interesting because they are one of the most common chemicals that you are exposed to on a daily basis. Many household items, many uh, foods and drinks are actually can be considered acids or bases. So when we refer to acids, we refer to materials that will have a sour taste and they have ability of dissolving metals. Dissolving metals because it is not a simple dissolution process like you figure dissolving sugar in water or dissolving salt in water. In this case, that dissolution process comes from a reaction that occurs between the acid and the metal. So the metal dissolves in that solution because the acid is reacting with that metal. Of course, there are acids and there are bases, and bases are pretty much the opposite of an acid. So, of course, both of them are very reactive and normally, and they will react with each other, acids and bases. And that reaction between acid and base is what we call neutralization. A little less useful is that when you have these acids and you use the litmus paper, and that's a old-fashioned name for pH paper. Well, there is a reaction there that changed the color of that paper. So usually, back in the days, one method that was used to identify whether you were in presence of an acid material or a basic material. Okay, so the ability of changing the blue litmus paper to red was a characteristic of an acid. Is that being used that? Yes and no. There are more sophisticated ways to determine whether a substance is an acid or a base. Common acids with the uses that we can encounter in everyday life, hydrochloric acid. Normally you find that in cleaning solutions. And that's the acid that is in your stomach. So your stomach is pretty corrosive, and it has to be so that you can digest foods, right? Sulfuric acid is another common acid. Nitric, probably the acetic acid, and the carbonic acid are ones that you are very familiar with. For example, who doesn't like a balsamic vinaigrette on your salad? Okay, so that's acetic acid there. Not in high concentration, but enough to give it that particular taste. The carbonic acid is that one that if you like soda drinks, carbonic acid is all over the place. Okay, so these are common acids that you might be exposed to. Sulfuric, nitric, and phosphoric acid have very many applications in the agriculture industry for manufacturing of fertilizers and some other things that are not so good, like explosive and stuff like that. There is a particular family of acids that we call organic acids, and we call it organic because of this particular group, the carboxylic group. And the carboxylic group pretty much is this structure here, COOH. Organic acids are particularly characterized by the presence of that group. You can have one group, you can have many groups. It doesn't matter how many you have. If you have at least one, you are going to be considered in organic acid. So the most common is acetic acid, but there is also citric acid. Both of them will have a carboxylic group there. And if you notice the structure here, you have these hydrogens there, and you have this hydrogen here. And the reason we write the formulas for those acids there is that we are referring to them as this and that being the acid hydrogens. So in a way, as we're gonna see with definitions later, the acidic hydrogen is what makes an acid an acid. Okay, so this over here these are non-acidic. As we're gonna see later in the chapter, the acid-base reaction implies the transfer of hydrogens at some point in the reaction. Okay, so for that to happen, the hydrogens have to come from somewhere, and those hydrogens have to be acidic hydrogens. Okay, so that means this hydrogen here can participate in an acid-base reaction. This here not able to participate, of course, in acid-base reactions. Okay, if you want a more in-depth on what the structure of a carboxylic group is, then you have it here. Okay, both oxygens are attached to the carbon, and the hydrogen, the acidic hydrogen, is attached to oxygen. Okay, so we can add that here. Acidic hydrogens are attached to oxygen, and remember, this is valid for carboxylic acids. Okay, this is for carboxylic acids. So if you see a hydrogen that is attached, if you have an organic acid, but you have a hydrogen that is attached to a carbon, that hydrogen will not be acidic. It has to be attached to a oxygen, and sometimes could be attached to sulfur. But for now, we are gonna stick to, we're gonna keep it simple. And in this case, if we are referring to carboxylic acid, it's gonna be COOH, and that H, that hydrogen, will be attached to oxygen. Now, if we go to the side of the bases, then bases are present in many household cleaning products, and there is a picture of some of them that you can see. Some of them would be familiar to you, some of them not. It doesn't matter, but they are considered bases. In terms of taste, not that I recommend you tasting Easy Off, for example, or Drano, but they taste bitter and often poisonous. And well, acids, they are not necessarily poisonous. I mean, you eat vinegar, for example. You consume carbonic acid, and for the most part, unless you consume a lot of those acids, you're gonna be perfectly fine. The opposite is not the opposite. For bases, well, the opposite is true. You can get hurt if you drink a product containing a base. Okay, it says feels slippery to the touch, and the reason for that is because if a base lands on your hand, then it starts hydrolyzing your skin, and what that means is start destroying your skin. So it feels slippery because you are rubbing your fingers, for example, into a layer of skin that is being destroyed. So of course, if the acid is able to neutralize a base, then the base is able to neutralize the acid. So that's what we call an acid-base reaction, and that's why we call those reactions a neutralization reaction. And in this case, back in the day again, if you have a base and you have now red litmus paper, then they have the ability to change it to blue. So again, this is a paper that was used to identify if you have an acid or a base. Now nowadays we still use paper, but they are a little fancier, if you will. You can collect more information. You can use, for example, if you have the red litmus paper, you can identify a base, but you cannot identify an acid. The current pH paper, litmus paper that you can use, then you can test whatever it is. It will give you an answer whether it's an acid or a base. Common bases: sodium hydroxide, potassium hydroxide, bicarbonate, carbonate, and ammonia. Those very common. Ammonia, particularly in detergents and fertilizers and explosive, unfortunately. and ammonia has a particular smell, so sometimes you can open one of these products and you can smell ammonia, and then okay, this is a basic product. For the most part, the other four, sodium hydroxide, potassium hydroxide, and the carbonate, they don't really have a particular smell. But baking soda is something that you use on a daily basis. Well, not daily basis, but it's a common household product. So when it comes to acids and bases, and we were saying that normally an acid-base reaction implies the transfer of a hydrogen, then we need to discuss about this ion, the hydronium ion, because when it comes to acids and bases, that is the most important ion that we're going to discuss in the entire chapter. Okay, and these are the key to acid base reactions for the most part. Okay, and the reason being is that this hydronium ion that we're gonna see very common in acid-base reactions comes from the fact that whenever you are transferring those protons, those hydrogens, they are being transferred in the form of H plus ions. However, this H plus ions is very special because it's very, very reactive. So if you have a aqueous solution and you have H plus ions there, they are never by themselves. They are so reactive that they will interact with something else. And what's more abundant in an aqueous solution? Well, water. So they associate with water, and usually they will produce something of this formula. Okay, that proton, that H plus ion, combined with any given number of water molecules. The most common of which is for N equal 1, which is one water molecule. So this is what you have here. The H plus will combine with one water molecule and will give rise to the hydronium ion. Structurally, basically what you're seeing here is the oxygen surrounded by 3 hydrogen atoms, and that ion will have, again, if water is neutral and you are coming with hydrogen with a 1 positive charge, the resulting ion will still have 1 positive charge. Okay, but again, this is the most important ion in the whole acid-base chapter. Okay, it's all about where is that ion coming from and where is that ion going to. Okay, so that's pretty much all we want to do, and or we want to understand, and we will understand that on the basis of chemical equilibrium. So acid-base reactions oftentimes are also referred as equilibrium reactions, depending on what the nature of the acid and the nature of the base, but more on that later. So for now, that's it.